We move on to difference in differences. As before, I will very quickly show you the analysis conducted for a paper. And then we will consider the empirical application. In this paper, we assessed the impact of the indirect cost compensation under the EU ETS on firm performance. I don't know if you are familiar with the EU emission trading system, which is the largest trading system of emission allowances worldwide. The goal is to create a carbon price signal based on a cap and trade mechanism. It targets energy intensive installation and aircrafts. And we have on the one side, it provides direct, it provides compensation to direct costs, as businesses should buy CO2 certificates, which are equivalent to their industrial emission. So it's like a system in which business exchange CO2 allowances. Then firms might incur in an additional cost due to the higher electricity prices that are practiced by the power generator that provide energy supply. And that have to increase energy prices because they increase their cost given to the direct cost of the EU emission trading system. The second type of costs are called indirect costs because are indirect paid by firms that are energy intensive and buy electricity from power generator. One of the risks of the ETS is the carbon leakage, which is, so you know that the Commission has set some quite strict environmental goals by 2030 and 2040 that are highlighted in the European Green Deal. However, given these strict rules and the cost in which they incur for the EU ETS, some companies might decide to relocate in a different country in which there are no rules and no caps on the emission. This is what is happening, and this is detrimental also for the ultimate goal of the policy, which is the reduction of the emissions. So the ETS directive provides compensation both for direct and indirect costs. In this paper, we will focus on the indirect cost compensation. And in the literature, there are several papers assessing the impact of the EU ETS on firms' emission, but there are only a few papers assessing the effect on firm performance, and yet there is no consensus on the effect of the ETS on firm performance, as some of the papers find a negative effect, other a positive, and other a not significant effect. In this study, we focus on the beneficiaries, on the indirect cost compensation, so the compensation for the higher electricity cost, which is only provided by a subset of member states. So not all the European member states agreed to compensate for the indirect costs, and it only affects some sectors that are listed in the ETS guidelines. To carry out the analysis, we have records on the beneficiaries of the indirect cost compensation that were provided by DG Competition for these countries, which are Germany, Netherlands, Spain, Belgium, Finland, and the UK. We have information on the firm and the amount received. These information are confidential, so in the anonymized data set that I provided to you, the amount is a fake amount. Then we linked this information with Orbis database, and we look at some measure of competitiveness, such as labor productivity and assets per employee, and firm performance, such as operating revenues, turnover, number of employees, and total assets. The two sources of information are matched using probabilistic matching. And in the end, we have a panel of about 3,700 firms. It's heterogeneous, yeah. Here you have some descriptives that I skipped. And you see it's heterogeneous also the amount of subsidy, because there is a formula based on benchmark to compute the amount. Let's look at the model we apply. We apply a difference in differences approach. Our treated group consists of firms in aided countries, in aided sectors in aided countries. The control group consists of firms in aided sectors in non-aided countries. And the time span ranges from 2009 to 2017. And the treatment starts in 2013 for the vast majority of countries, except Finland, that starts in 2016, and Wallonia, that starts in 2017. So you see, as I showed in the presentation this morning, that there is a bit of staggered adoption. It's not a proper staggered setting, but you see there is the bulk of countries that is there is the bulk of countries that is adopting the indirect compensation from 2013 onwards. To a country and part of a country that started later on, and these are never treated. Okay. In our model, we account for time, firm, and sector year unobservable characteristics, and for time varying country specific variables. And we measure the treatment in two ways. We look at the extensive margin, so we consider the treatment as a dummy variable, which takes value 1 if the firm is deemed to receive indirect cost compensation, because it operates in a country and in a sector that are aided, and 0 otherwise. And then we look at the intensive margin. So in the subset of treated firms, we consider the relationship between the outcome and the amount of the subsidy. Okay, so here you see the visual inspection of the parallel trend assumption. So we plot the different outcomes for the group of beneficiaries and the non-beneficiaries. Then we estimate the effect on the extensive margin, and you see that we obtain no effect when we look at per employee measure, and we obtain a slightly negative effect when we consider measure in absolute terms. Here you see the results of what before the event study analysis, in which we explore the dynamics of the effect in the pre-treatment period to validate the parallel trend hypothesis, and in the post-treatment period. And you see that for some of the outcomes, the effect materializes a few years after the treatment. Then we did some robustness, which are the exclusion of countries one by one to test if the result is driven by a single country, and analogously the exclusion of sector one by one to see if the result is driven by a single sector. What we observe is that firms in the treated group are substantially larger than firms in the controls, and that there might be some elements that we cannot observe in the analysis, such as the contract for electricity supply, which is so detailed information that we don't have. Then we look at the effect on the intensive margin. So here you see we have a few observations because these are only the treated units. And we observe that there is a positive relationship between the turnover, the outcomes in general, and the subsidy, meaning that the higher the subsidy, the larger the outcome. I will now show you on the empirical side how this analysis is carried out. So this is here. State is it, and it's ETS. Okay. You have the file in the shared folder, but you can follow me. As I said before, this is a subset of the data, and you also have anonymized information, so you're not able to identify firms, country, and so on. Sorry? No, this is in the DID subfolder. So we first define the fixed effects that we are using, and we cluster the standard error clustering. So first of all, this is these are some descriptive statistics that is useful to run to understand how balanced is the outcome treated and control group, and also to eventually detect some outliers, or if you need to trim your sample. In this case, in the paper, you will find all the information. We trimmed the sample because it was unbalanced between treated and controls. And we had to focus on similar firms. As an alternative, in this case, you could have also run some matching to identify the best controls. Then for the descriptives, you could also use the command xtdes to have information about the distribution. For instance, here you have xtdes for the beneficiaries, and you see which are the frequency and unique values and so on. This is still some preliminaries. Let's look at the parallel trend descriptive graphs. As I said before, these provide an intuition of the validity of parallel trend assumptions. So what I'm doing is creating all the variables that I need to plot using TS line the trend of the outcome. So here you see as the thick line is the trend of the log of turnover for the non-beneficiaries, and the dashed line are the respective confidence intervals. And the dotted line instead is the trend for the beneficiaries, and the dashed line are here again the confidence intervals for the beneficiaries. The same you can do for all the other variables. You don't. No, it's more about the yeah, it's not relevant for us. Yeah, it's here you see in some cases you might have that confidence interval overlap. So it's not only a matter of trend, but they also have more or less the same value. In this case, you see the confidence interval do not overlap. So they are statistically different in the values, and you see that the beneficiaries have on average a higher turnover with respect to non-beneficiaries. The important thing for the application of the RDD is the parallel trend. So the two lines should be more or less parallel. It is also true that this provides only descriptive insights because you only have the line of the outcome, so you're not accounting for fixed effects that still help to account for unobserved heterogeneity. Regression. Let's estimate two models. The first one in which we regress the outcome over the treatment. Our treatment variable is aid. I will provide you a tab, TIA aid here. So you see, it's always 0 before 2013 because no one is treated before 2013, and then it becomes 1. And if TIA aid CC code, here you have how these varies by country. So country 1, for instance, you will have that country 9 is a control. You see it's always 0. Country 10 is a control. Country 11 is a control. Country 6 is a control. So, and then we run the same regression, but we include among the absorbed fixed effect, NACE by year fixed effect. So these allow to account for unobserved heterogeneity that is specific of a sector in a given year. And that's clean your effect. Okay, this is done in loop, so you have a lot of estimates, but let's focus on one. So here we are considering the log of employment, and we observe a negative and marginally significant coefficient. So this tells us that firms operating in aided sectors in aided countries experienced a reduction of their number of employees as an effect of the ETS indirect cost compensation. Here we do the event study analysis. So in the event study analysis, you disentangle the effect year by year. So here we have the pre-treatment dummies, And here we have the post-treatment dummies. I will show you how they are defined. So you see, this is the same firm. Oops. And 8.0 is a dummy which is equal to 1 the first year and 0 otherwise. 8.1 is a dummy which is equal to 1 the second year and 0 otherwise, and so on. In the event study analysis, given that we are including dummies, so we should exclude 1 to avoid collinearity issues, we keep as a reference year the year before the treatment starts. So in our case is 8.3. Then we run the same estimate as before, and we use the command coefplot. In this case, we are plotting more for fashion to get attractive results. The confidence bands for different sensitivity levels. So we consider 90, 95, and 99% confidence intervals. The blue dots are the point estimates, and the vertical whiskers are the confidence intervals. You see that none of the pre-treatment coefficient is statistically different from 0, meaning that the parallel trend assumption holds and there is no anticipation of the policy. In this case, we observe also that we find no effect even in the post-treatment period, except for 5 years after the implementation. And then you can do some robustness, for instance, introducing specific linear trends. In this case, it's introduced at the NACE level, so sector-specific linear trends. And this high point NNA's C point here identifies the linear trends because considers year as a continuous variable which introduces a linear trend in the analysis. And then you might see how results change when you include linear trends. Here we have the robustness I showed you before, which is the exclusion of a country one by one. Here something happened. So, and then you can consider aid intensity. So in this case, we are looking at the intensive margin. So we are seeing how the outcome is affected by a different level of the treatment of the subsidy. So we are not comparing treated and controls, but we are looking within treatment group at different intensity. A more appropriate way to test the intensive margin is to use generalized propensity score matching, in which you estimate dose response function. So for each dose of your treatment, you observe the response of the outcome. And in this way, you are able to identify which is the optimal dose of your treatment. So if you need, if you are spending too much and maybe you can save money by giving lower funds, or maybe if you want to, if you are not giving a sufficient amount of money to trigger growth or to reach the desired effect. Question? I have more a picture country. The question of money has the second part to publish the response to the aid. Okay, so you mean these are country specific. So yeah, could be. We are considering all together. Okay, but you could also, if you want to account for the country effect, you might add country fixed effect, and then you are cleaning your data. Okay. Other question on this? No. Then we go with the last application. That was also cited in one of the video that I showed you, which is about the evaluation of the late payment directive on the economic performance of the firms. Actually, if you have a look to the evaluation of this directive, you will find more than one study, because the directive is quite complex and has a provision that regulate both public administration to business transaction and business to business transaction. In the analysis that I will describe, we are focusing on the public administration to business transaction. So the transaction that the commercial transactions that firms have with the public administration. In this case, we are exploring one of the particular case of the more, let's say, sophisticated analysis with difference in differences. And you will see in a while why this is not a baseline difference in differences. First of all, why we conducted this analysis, because delayed payment have substantive economic consequences as increase administrative and financial costs, reduce firm liquidity, so they become a commercial credit for firms for which they do not receive interest. So there has been a lot of attention by the European Commission in trying to regulate the payment terms with several directives. Here we are considering the directive in 2009, and we focus on business performance, and in particular firm exit rate, employment and investment, and we consider public administration to business transaction. The period of analysis is 2008-2015, and the directive established a maximum payment period, which was set to 30 days in the PA2B transaction, with the exception of the health sector, and introduced a straightforward entitlement to interest, and introduced the definition of unfair commercial practices. So the goal was to reduce cost to business and decrease default risk. Directive affected all European countries in all sectors. So to evaluate the effect of this regulation, we had to find some source of variability in the directive implementation, and we exploited two dimensions. First of all, we looked at the financial dependence on the public administration of each sector in a given country. So we built a measure of administration, of exposure to transaction with the public administration, based on the information you have in the input-output matrix. So for each sector, we were able to define how, to what extent that sector was dependent from commercial transaction with the government. And then we exploit information at the country industry level before and after the introduction of the directive. And we also exploited the staggered adoption of the directive by member states. So we are, let's say, combining a staggered difference in differences and the difference in differences based on a continuous measure of exposure. As I said before, the PA dependence is extracted from the input-output tables. It's clear, it's easier to understand if we look at this table. So imagine you have this sector, machinery, construction, and public administration. Machinery, the flow of transaction between machinery and machinery is 10, machinery and construction 25, and machinery to public administration is 20. Total in million of transaction for machinery is 55. Our PA dependency will be 20 over 55, so it's 36%. So firms operating in this sector were exposed to transaction with the public administration for a measure of 36%. Then you see there was heterogeneity in the adoption of the late payment directive across EU member states, with the bulk of countries adopting the directive in 2013. We combined different sources of data, data on firm performance. This analysis is conducted at the sectoral level. And we have information in particular extracted from the structural and business statistics of the Eurostat. The dependence variable is computed by using the word input-output database. And then we use controls taken from the World Bank and Eurostat. So this is these are descriptives on the sector dependence on the public administration. And the empirical model is in the end quite simple, because we have the outcome that varies at sector by sector, country, and time. The variable of interest, so our treatment, is this interaction between dependence and cost that identifies the treated groups. However, you see that dependence is a continuous variable, it's not a dummy. So we will interpret the effect considered by always comparing high level of dependence to low level of dependence, because as you know, this effect varies according to the values assumed by the continuous variable, as it happens in the interaction types. And then we control for a battery of fixed effects at the country by time, sector by time, sector by country, and sector by country linear trend to account for unobserved heterogeneity. And we also include a vector of covariates at the country level. Then these are the results on firms exit rate, and you see that the directive reduced firms exit from the market in sector more exposed to the public administration transaction compared to sector less exposed. And so you consider sector with low degree of exposure compared to sector with high degree of exposure. For instance, retail and trade and construction sector. And you compute the difference between the two effects, and this gives you an estimate of your impact. We also did some heterogeneity analysis, which is quite common when you do a difference in differences. So In our case, we considered a heterogeneous group of sectors based on the size of the firms to see if the effect is more or less marked for a sector where there is a large share of small firms. And this is how the effect varies. So the effect is larger when there are more small firms, and this is quite expected because small firms are those that are more exposed to the risk of default for the late payment of the public administration. And then we have also heterogeneity according to a measure of payment duration that is provided by Info Justitia. I don't know if you know this. This is a private company which runs a survey in European countries and collects data on the average payment duration of different type of transaction. And we checked whether the effect was heterogeneous according to this observed level of payment duration. And here again, the effect is larger in those sectors that were previously experiencing longer payment terms, meaning that the directive was more effective where there was more need to be of regulation. Then we, as I told you this morning, we considered a fake treatment period. So we simply changed the year of treatment, moving it back in time, and we found no effect. So this validates the results. And we also consider interaction with other macroeconomic variables. Finally, we test the common trend assumption by implementing an event study analysis. So when we conducted this analysis, there were not already published all the papers of Callaway and Sant'Anna that are now introducing a package to run the staggered difference in differences, and there was no honest deed package and event study package. Now, what we were previously doing manually is done by a SATA package. So here you see that there was no effect prior to the adoption of the directive, and then there is. And then as a robustness, again, here we use different values of the input-output matrix to compute the exposure variable. We exclude sector one by one, and we exclude country one by one. Results sold, we also consider different outcome variables. I will show you very quickly the code. Okay. Okay. Input. So here we are defining the variable cost, because in the basic difference in differences, you have a variable treat that identifies your treated group and a variable cost that identifies your post-treatment period. And then you interact the two in the model. So here we define the post-treatment, the variable cost, which is equal to 1 after the adoption of the late payment, and changes according to the country, because as I said before, the implementation was heterogeneous. then we should combine this post-treatment variable with the dependence, because in our case, we are not able to identify treated and controls with a dummy, but we identify more exposed to the treatment versus less exposed to the treatment. So instead of interacting post with the treatment dummy, we interact post with a continuous variable, which is our dependence from the public administration. In this case, we have more exposed and less exposed. These are the other variables that we need. Then we were using weights to avoid having the results driven by large firms. So we are reweighting estimates according to the FTE. We define the balance sample because we also check if results hold when we consider the balance panel or not. So the usual robustness. And the descriptive sentence scheme. So here you have the baseline model. You see the variable of interest is dependence, but these results varies according to the level of exposure to the transaction with the public administration. So to interpret these results, you should compute the linear combination for different values of dependence. For instance, here we are considering the difference between the effect that we observe for those that had a dependence of 5.12% with respect to those that have a level of dependence which is of about 1.6%. And we observe that for those that were less exposed to transaction, those that were more exposed to transaction with the public administration experienced a decrease in the firm's exit compared to those that were less exposed to transaction with public administration. Here we have heterogeneities in which since, for instance, the variable with which we do the heterogeneity is still a continuous variable, which is this interim variable that measures average payment duration. Again, we use an interaction term, and then we assess how the effect varies according to different values of this continuous variable. As a robustness, you can exclude a given country. You can exclude a given sector. Here we compute the average, dependence from the public administration using a different input-output matrix. And I want to show you the falsification exercise that we didn't see before. So here we set the post, the post treatment 2 years before the real one. In which case we expect to find no effect because 2 years before there was no regulation. We can't consider 2 years after because the regulation was already in place, and so we will find something.
Here, amount of money. Maybe similarly each year I cannot be an effect, but the cumulative effect will appear 2 or 3 years.
Yeah. Yeah. You might see that in this way we are we want to see if there was an effect by going back in time.
It's cumulative.
No.
No.
It's let's imagine that let's see if it's a sensitivity check. So I want to see if the result I'm finding with my model is truly due to the directive and was not there before the directive was in place. If I find something when the directive was not in place, then there might be an issue because probably the effect I'm detecting is due to something else. And what you say is possible to be considered when you do the event study. So actually, what you see with the normal estimate is the average over the post-treatment period. So it's what you call cumulative effect.
The model has to be the effect of presence or absence of the treatment, or they can also capture the marginal effect of the amount that I'm putting. But if I pay €1 or €2 or €3, the model captures the effect of the amount of the payment, the marginal effect. If I pay more, I have more.
Not this model because we are not considering the amount you pay.
It's not a marginal amount.
No. And then if you want to see the dynamic of the effect, you can structure the analysis as an event study in which you consider the effect year by year. So the results we obtain here with this fake data set, of course, are not coherent with what we obtain in the proper study. It's just illustrative. Okay.